Clean, not clean. Ooh,
Anyways,
I'm liking these kind of questions.
that's the thing. They're all like this, and I'm so bad at these because I don't know how to set up the question. So, like, should I? Can you see this, or can I go back to Discord? Guess you can. Like
So
this?
let me look at the question here. Let me gotta get all set up. I'll launch Paint. Gotta find my tablet. Gotta load up the driver. Gotta put it in negative mode. Put my music on.
At this point, I don't even know how to study for this class anymore.
Just all math, baby. It's all math. Oh,
Sorry,
what
I
do you
just saw your
do?
sleep text that emailed me. Anyways,
Oh, look. All right, at noon, okay? So,
I started with saying that dA over dt is 45 kilometers an hour, and dB
okay,
over dt is 25 kilometers an hour, because that's velocity, right?
okay. But you should
Alright.
notice something here. So, which direction is ship A traveling?
Traveling south,
Okay, so let's call that negative 45.
negative.
Because it's going down at 45 kilometers per hour.
Does the direction really matter? Because then what would you call west and east?
Oh, here. Here's what I would do, right?
Apparently they did a Pythagorean theorem, like in the
Yeah.
student things, but like, even then,
Here's ship A. So imagine you're sitting on ship A.
wait, hold on. Okay,
You gotta like share the video, share the window and not like your screen so I can see the question. Yeah, much better. Okay. And then you can just do whatever you want. Okay. Okay, so ship A is 150 kilometers west of B. So this is at noon.
You're not streaming.
Oh yeah, you're right. Okay. So we're at high noon. Okay. We have ship A.
Hold up,
We
how
have,
do I?
we have ship B.
Uh, One sec, I'm trying to find your stream right now.
Okay.
Got it.
Found it.
Yep. Yes, yes, yes. Okay, so we have ship A.
We have ship B.
Mm-hmm.
Okay. And they're
Okay.
150 kilometers apart. Okay.
Okay.
So this distance between them is 150 kilometers. Okay.
Yep.
All right.
Yes.
Ship A starts sailing this direction, right?
Okay.
And ship B starts sailing this direction.
Yep.
Okay.
Yep.
There's a different way you can look at this, right? So imagine you're in a car, right?
Mm-hmm.
Relative to the car, you're not moving, right? Because you're sitting in the car, right?
Okay.
So now imagine you're on a road and there's a car coming the other direction, right? And you pass by each other, right? You're both going in opposite directions, but to you, it looks like the car is coming towards you. And when you go right past each other, the car looks like it's going really fast, right?
Alright.
That's
Yeah.
because you're moving in one direction and the car's moving in the other direction, right? And so what happens is they add up, right? These velocities add up, okay? So you can write this a different way. You can say that A is stationary, okay? just say A is stationary, and now we have B is still going to be going its distance, right? Or its speed, right? But on top of that, let's put the speed of A as well. Okay? Because if we do it this way, right?
Yeah.
You'll notice that the distance here, it's constantly like changing, right? It's like it's getting weirder, right? It's doing shit like that, right? It's like twisting, right? But if we do it this way, the distance is just getting steeper and steeper, right? Because this point is just traveling up this line here.
So
Okay?
then, what is what's it called? If I like when I did this, right, and I put it in Google,
Okay.
it showed me it showed me this thing. What is this?
That's what we're getting to.
But like, notice it says like this is the A, and then this is the B. This one goes up. This one goes down.
Correct.
Right.
Yeah.
So, what are you saying about the twisting thing? There's no twisting here.
Because look at that line, that diagonal line.
Oh, yeah.
As they get further apart, that line's getting steeper, right? So Matt, hold your pen. Hold on.
Sorry, what were you saying?
Hold your pen in between your two fingers, right?
Okay.
And now move your right hand up and your left hand down. That's what's happening. Is that your left hand is A, your right hand's B.
Yeah.
A is going down, B is going up, right? So this whole thing is like twisting, right? So it's kind of weird looking. But if we do it the way on the right here, if we do it this way, what's happening is the left side is staying stationary and the right side is just going up. Okay? So it's just a little bit easier because you have a fixed point instead of a moving point. You have one fixed point and one moving point instead of two moving points, right?
Yeah. I don't know, man. So, like, I just hate this shit about diagrams. Like, I just have dA over dt, 45 kilometers an hour. dB over dt is 25 kilometers an hour. And we want dz over dt at 4 p.m. And z is the distance between A and B.
Correct.
But, like, I don't understand any of this, like, diagram shit.
Okay, so well, you gonna let me fucking explain, or are you just gonna keep crying about it? Okay, here we have A, right? A is fixed. This point's not gonna move. And this is 150. I'm just gonna draw a blue line. Is that distance ever gonna change?
No.
No, because this boat is going up, right? Okay. Now, this boat is going up to some random point. I don't know where it's going, but it's going to go, like, say, up here, right?
Okay.
And this distance here changes, right? Let's just call this distance y, okay? Whatever y is, I don't know what it is, but I know y changes with respect to time. And it changes as dB dt plus dA dt, right? Because that's what this represents. Okay? So it's going to be 70 kilometers per hour. Okay? All right.
Sick.
And so this distance, let's call this x. How fast is this changing?
Doesn't change.
So what's dx dt?
It's like 0.
0. Okay. Now this is the distance between it. Z. Okay? Now, Z equals the square root of x squared plus y squared, right?
Sure, yeah.
So now we're going to take the derivative of this with respect to t. Okay? So we're going to get dz dt. Okay? Now I have to take the derivative of this. Oh, sorry. Forgot the square root. Okay.
Is equal to 70 kilometers now?
Yeah, because I just added them up. It doesn't really matter.
I'm pretty sure that he wouldn't expect us to know that thing about the whole like add it up together or whatever.
This is just a physics.
No, I know. I'm just saying like, how would you do it if I didn't have that knowledge? Because I did not have that knowledge.
Well, now you have that knowledge. What do you mean?
Well, like the way the other students did it is what I'm asking.
I don't know. That's not how I'm doing it. I don't know why you would want to do it that way. It's more difficult.
Okay.
Doesn't just take the dirt, because what? How is this? Does this look hard to you? Does a triangle look hard to you? Or okay, all right, fine. Okay, let's do it your dumb fucking way. Where you do this, right? So you have 2 points now.
Yep.
And now you have another point here. And by the way, you didn't know either one, so I don't know why you want to do it this way. But anyways, and you have this fixed distance here, right? And now you're moving up, and you're also moving down.
Okay.
Right? And now you're moving. Now you have a line like this, right?
Yeah.
Okay. So this whole distance is z.
So you can do it this way?
Do what way?
The way you're doing right now, like it works. The way
This?
You're doing it? Yeah.
Yeah. Because I just need to make, because these are right triangles, right?
Yeah.
Right. Well, here, watch this. If I shift this line up, like if I were to grab this yellow line and shift it up so that it's level with here, this would look like this, right? So if I just have this blue line here, and then I shift it, the yellow line up so that it looks like this, what happens is you have this green line here, and then you shift it up the red line. Which is where all of this comes from. This is like the mathematical version of the physics. This is, it's a mathematical proof of the physics, right? Because here I have 2 triangles, right?
Yeah.
So why would I want to solve 2 triangles simultaneously when I could solve 1 triangle? Right?
Yeah, I'm just trying to figure out how to like. I'm trying to pull like the bottom part to the top. It doesn't give me the same image that you drew though, so I'm kind of confused.
I have to do what? What do you want to do?
Pull the bottom part to the top.
The bottom part, this?
Yeah, pull that up.
Yeah, so what you're doing is you're taking this yellow line here. Okay, here. Let's go like this. Okay. So we have the 150 meters, right?
Yep.
Then we have some distance like this, right? Let's bring this down here. And now this red ship's going down. It's going down a little faster, so it goes further distance.
Okay.
Okay. And now we have the distance between the two. Like this, right?
Yeah.
What I want to do, I didn't want to. So we have this distance here, right? What I want to do is I want to shift this line up so that it's right here, right?
Okay.
So I just did a vertical shift.
Yeah.
Okay. I didn't change the distance. I didn't change the angle. I just shifted it up. Okay.
Right.
So how far did I shift it up? Well,
9.
Yeah, it shifted it up the distance of the red line. Okay, so if I want to make a triangle, I just need to take this red line here, right, and copy it right here. And now I have one triangle instead of two triangles, right? It's the same numbers, you know. I didn't change any numbers, but everything is sort of the same, right? And this is the same thing, and this is like a mathematical geometrical proof of a physical system, right? So imagine you're in a car, right? And you throw a ball backwards, right? And this is sort of like a classic example, right? So you're in a car. Okay? You're hanging out the window. You're brown.
Right.
You're hanging out the
Yeah.
Yeah. Right? And the car is moving to the left, okay? So
Okay.
you're flying along. You have a baseball. Okay?
Yeah.
And let's say you're flying to the left at, you're pretty weak. So let's say you're flying to the left at 40 miles per hour, and you throw the baseball to the right at 40 miles per hour.
Okay.
Right? What happens to the baseball?
Would it just like stay still?
Yeah, it stays still and it just drops to the ground. Because what happens is you're in the car. Okay, so the car's moving 40 miles an hour.
Yep.
You're in the car, which means you're also moving 40 miles per hour, correct?
Yeah.
And you're holding the baseball, which means the baseball is also traveling at 40 miles per hour.
Okay.
But then you throw the ball so that it looks like it's going 40 miles per hour the other direction. But really, because you're already moving 40 miles an hour, it cancels out, and so the ball just drops straight to the ground, right? So let's say I'm standing over here on the sidewalk, and I see you do this. What I see is the ball goes straight down.
Okay.
What you see is the ball's going straight down, but you're moving away in the car, right?
Right.
So the ball, to you, it looks like the ball's traveling away from you, right?
Yeah.
But really, what's happening is the ball is traveling straight down. Because to you, you're looking at it from over here, and you're looking at the ball traveling down, right? As you're getting further and further along the path, right?
But if you threw it behind you, wouldn't like the wind or some shit like?
Well, okay, now you're talking about wind resistance and stuff, which wind will have an effect on it. But really, in an ideal situation, it would drop straight down. But yes, you are right. There's wind, there's spin, you put spin on the ball, there's all sorts of factors that we can take into account. But this is the basic formula of it, right? And this is what I'm saying, is that A is moving down and B is moving up, right? So because they're moving in opposite directions, what happens is if I'm on ship A, to me, it looks like B is...
Could you draw like an imaginary triangle though, kind of? Like if you were to take the green line that you have in your first triangle, if you were to draw a bunch of dotted lines, right?
This triangle?
No, the other one, the one on top.
This one?
Yeah, draw a bunch of dotted lines under the green line. Under the green line?
Like this?
Yeah, like dotted lines down. No. The bottom part of the green line. The bottom part of the green line, dotted lines that go straight down. Yeah, and then you make a triangle with the big
Yeah. Oh, so yeah, that's the same thing. You could move. You could do it this way, but this is sort of. I mean, it works. You'll get the same triangle, right?
Yeah.
But physically, it's sort of hard to understand what this means, because it's like. It's sort of the same idea, right? It means like you've traveled. If I was at this point, it looks like at this point here, right? This is point A now. At this point, it looks like this ship, this blue ship, or this green ship has traveled this distance up, and then the green distance up. From the perspective of this ship, right?
Right.
You can do the
So
same
where's
thing.
B? So where's B?
B would be right here. You can do the same thing from the green ship's perspective. From the green ship's perspective, you know, you're still the same distance apart, but it looks like the ship has traveled this distance down and then this distance down. Right? But it's still the same triangle, right?
Right.
This thing is still just the opposite of that, right?
Mm-hmm.
So it's nothing really all that fancy. But anyways, you do all this just so you can find out, like, hey, okay, you know.
So
now I have
A plus
this.
B, I have 150, and I have Z.
Exactly. So you know this distance here, x. I'm just calling it x. This is going to be the horizontal distance between the ships, right?
Yep.
Right. So here, let me just make this like orange or something. Okay. Actually, let me just redo all of this because this is just some point, right? This is where the green ship started, was that orange point, right? And then by 4 p.m. it traveled up its green distance as well as, well, here we can do, traveled up the red distance as well as traveled up the green distance.
Okay.
Right. And so
Yep.
this is, let's just call this like distance B, and we'll call this distance A. You know, I don't really know how far it covered, right? Right. I know this is at 4 p.m. We'll get into that later. And I know all of this equals y, right? If I add these up, it equals y, right?
Yeah.
It's the vertical distance between A and B. Okay? So from here, we don't really know what y is, but we can figure it out. But we do know what dy dt is, right? Because we know how fast B is going. We know how fast A is going, right? And so when we take the derivatives of these, that's when we get 70 kilometers per hour, right? Because dB dt, as you call it, is 25, right?
No, 45.
And dA,
It's 40.
and then ship A is going at 45.
Yeah.
Right, and so then we just add these up. You'll notice that dy dt is changing at 70 kilometers per hour.
Wait, why do you get dy dt?
Because this whole distance, this whole length here is y, so I want to find the change in y. Right? And so, if y, and here, I don't want to call these A and B because I labeled the points A and B, but I guess it doesn't really matter. So let's just do this again. We can say this is distance A.
Okay.
And this is distance B.
Okay.
And from this, we say y equals A plus B, right?
Yep.
Yeah.
Yeah.
So then, when we take the derivative with respect to time, okay? So dy dt equals d dt of A plus B.
Yep.
We get that dy dt equals dA dt plus dB dt.
Oh, you do that because you're distributing the.
Yep.
You're
So,
multiplying it?
yeah, you do each of them individually, right? Because they're adding, right?
Okay. There's no chain rule, I think, but yeah. Okay.
Nope. No chain rule here.
Okay.
Okay, so then you get dy dt equals 45 plus 25, 70 kilometers per hour. Okay?
Mm-hmm. Yeah.
So now we have z. Okay? Z is a little more interesting because z is now the Pythagorean theorem. So it's going to be x squared plus y squared equals z squared, right?
Yeah.
So let's get rid of all this shit.
Wait, so can you not just do like 150 squared plus 70 squared is equal to z squared?
No, because this is 70 kilometers per hour. This is okay. So
150
right.
kilometers?
So and here, let's go back to x as well. So x is equal to 150 kilometers, right?
Yeah.
So when you take the derivative of that, dx dt equals d dt of 150. Right? What's the derivative of 150?
With respect to t.
Okay.
Oh, it's just a constant though, so it's 0.
0.
Yeah.
So we have x, we have dx dt, and we have dy dt. Okay?
Okay.
So we can't really solve for it yet. Right? And by the way, the question is asking, what is dz dt?
Yeah.
That's what it's asking
4
for.
p.m. Yeah.
Right. Start this here. Find dz dt when t equals 4. And I'll
Yeah.
explain. I'll explain this. Do you know why it's t equals 4?
It's the time.
It's the time. Well, it's because we start at 12 p.m. and then we go to 4 p.m. Right?
Yeah.
So this would be time equals 0. Right? I would just set this equal to my starting time, right? And then we add 4 hours. So this would be t equals 4, right?
Right.
Okay. So now we need to find dz dt, right? So to find dz dt, we need to find out what z is so we can take the derivative of it, right? And so like we said, we know that x squared plus y squared equals z squared. This is Pythagorean theorem, right?
Yeah.
So then z equals the square root of x squared plus y squared. Okay. Not too
What
bad.
do you mean?
What do you mean?
Square root. Why is there square root?
Because I solved for z.
Oh, yeah, sorry, yeah.
Yeah, now we take the derivative. So dz dt equals d dt of the square root of this. Yikes. Not fun. Well, we have to take the derivative of this, right? And you'll notice we have to do chain rule twice.
Why?
Because we have dx, we're going to have x, and we're going to have dx dt. And we're going to have y, and we're going to have dy dt. So just follow me for a second here. This is a really tricky one, okay? So we're going to take the derivative of the outside, right?
Yeah, the outside is square root x.
Right. Well, yeah. So we're going to have this, right?
I don't know how you did that.
This is the derivative of the outside, right?
The derivative of square. Oh, it's because 1/2. So then you do negative.
Right.
1/2. Wait.
Exactly. It's all over 1, right? 1/2 times 1 over.
Wait, no. X squared plus y squared to the power of 1/2.
All right, here, look. Square root of x, if I take the derivative, it's going to be 1/2 x to the negative 1/2, right? So this equals 1 over 2 root x. That's what I did here. Okay?
Yeah.
Now we have to take the derivative of the inside, right?
Okay.
So now we have this. Right?
Yeah.
But we have to do the chain rule again because this is with respect to t.
No, but don't you have to do it with respect to t for the outside as well?
Nope. Because because that's the definition of the chain rule. Remember, it's you have to you change the variable to take the derivative. So to take the derivative of this, we took the derivative with respect to x squared plus y squared. I know you hate when I do it this way, but you're not following it. So basically what I did was I had d dt of square root x squared plus y squared, like this, right?
Yep.
I don't know how to do this, so I did dx squared y squared times dx squared y squared dt, right? So this is the chain rule, right? So this is equal to this, okay? So I didn't take the derivative of this function with respect to t, I took it with respect to x squared plus y squared. So now I have d dx squared plus y squared of the square root of x squared plus y squared, right?
Right.
Times d dt of x squared plus y squared. Okay?
Okay.
And so this part right here, it's just a different color. This part right here is this, right? Because I'm taking,
Okay.
right? Because this is just think of this as a variable, right? This is smiley face, and you're taking the derivative of the square root of smiley face with respect to smiley face, right? It doesn't fucking matter, right? This whole thing is a variable, and I'm taking the square root of that variable, right? Now, just because it looks nasty, x squared plus y squared, doesn't mean anything, right? This is a variable, this is the same variable. Okay, and now we have to take, so that's how we got this. Now we have to take the derivative of this. But the same issue arises where we're taking the derivative of x squared with respect to t, right? And y squared with respect to t. Okay? So I'm gonna right, so x and y, they're both variables, but they're not t, right? So I'm just gonna do x squared, and y squared will look the same, except everywhere I see an x, it'll be a y, right? Because this is x squared, this is y squared, right? They're gonna behave the same. And I'll show you what I mean. So we're gonna do this, okay? And really this is plus d dt y squared like this, right? But we'll
You can do that?
Yeah, you can break it up because they're adding, right? You can distribute the d dt to both the terms if they're adding. That's what we did over here.
Okay.
Right? Okay.
Yeah.
So now we have this, but I don't know how to take the derivative of that. So I need to change this to x. So I'm going to do d dx.
Wait, is this the chain rule again?
Yep, we have to do the chain rule again.
What's the outside?
That's the outside squared. The squared. So you'll get this, which becomes...
Holy. Wait, so the outside is x squared and the inside is 2?
The inside's x. Right? So I know how to take the derivative of d dt of x. This sounds kind of goofy, but this is just dx dt, right? But I don't know how to do x squared because they're different variables, right? I can leave it like this. This is fine because I can solve for dx dt. I can't solve for dx squared dt. So we have to do the chain rule. So I changed my...
I just want to know what my outside and my inside are for x squared.
Your outside's the squared and your inside's x. Because it's x with respect to t. And so what happens
So
is...
my outside is x squared and my inside is x.
You have to stop saying that. It's not true. I've been telling you this since day one. Every time you say that, it's just not true. You're saying your outside's x squared. Your outside is squaring it. That's the function. Is you're squaring it. You're squaring the inside.
Okay.
That's the function.
My outside is
squared. It's a
I
squared.
It's fucking
Sure. Whatever.
L
Anything.
squared, whatever.
Anything.
And then my inside would be x.
Right.
So
And so I
If you were to do it that way, how would you?
well, that's the thing. You can't really do it that way because it's with respect to a different variable, dt. Right? So, and really, all you have to do here is you take the derivative with respect to x. Right? So, dose the derivative of x squared with respect to x, just 2x. Then you multiply by dx dt. Right? And that's what this whole process is. I changed the variable of integration to x, right? So I can solve this, and then I have this term added on.
Okay.
Okay? And this is why you should learn the chain rule this way, is because it's much easier to understand this than trying to figure out what's inside and outside, because there's no real inside and outside if you have a different variable of integration, right? It doesn't matter. It's all the wrong shit. Right?
So then the other one would just be 2y dy over dt.
Exactly. And so, in total, you have this. dz dt equals 2x dx dt plus 2y dy dt over 2 square root x squared plus y squared. Alright? We took the derivative of this with respect to time. And then it's all over 2 over x squared plus y squared, right?
Right.
Okay. Now we can start plugging in numbers. Because we're plugging it in when t equals 4. Right? Okay, well, do we know what x is?
150.
150, good. Do we know what dx dt is?
0.
0, right? So this whole term becomes 0, right?
Yeah.
Because 2 times 150 times 0, that's just going to be 0.
Okay.
Okay? So that's good. It simplifies down. We also have a 2 here and a 2 in the numerator, so we can get rid of that. Right? So we end up with this. Okay. So, alright, now we're getting somewhere. We know what dy dt is, right? 70.
Wait. Relax. Wait. So, okay. The first part, right, is you multiplied by 1.
Where? What?
To get the 2x dx over dt plus dy over dt.
Yeah. I multiplied it by 1. Right?
Okay.
To get it in the numerator. Just so it's
okay, never mind.
more
succinct. So then 2x times dx dt is 0.
Why is it 0?
Because the dx dt is 0.
Perfect. Okay.
And then 2y dy dt.
Yeah, so this term's 0, so now we're left with 2y dy dt over 2 square root x squared plus y squared, right? So I just canceled out the 2's.
Oh, right. There's a 2 there.
So now we're left with this, okay?
Okay.
Now we know what dy dt is, right?
Right.
What is it?
Oh yeah, it's just dA plus dB.
Right. So we know what this is. Perfect. And we know what x is. Right? But we're left with the greatest question. Alright? The $1 million question. What is y? Right?
It's A plus B.
It's a plus b, right? So we know y is equal to a plus b. Okay, but now you have to ask yourself, what is a? What is b? Right? Do you know?
No, you don't.
You don't, right? So, I don't really know how far you've gotten talking about physics and stuff in this class.
I don't, not at all.
Well, that's not true, because I've seen your textbook. You've talked about physics in this class. So okay, so why is it distance, right?
Mhm.
So why is it distance? What is dy dt?
It's the velocity.
Right, it's a velocity. Right, but in this case, let's just think of it as speed. Right, because we don't really care about position right now. Okay, but you are right. It is velocity. You are 100% correct. Okay, and we know that this is equal to 70 kilometers per hour. Right. So if it's 70 kilometers per hour, how can we figure out how far we've gone in 4 hours? If we're going at 70 kilometers per hour,
You just multiply by 4.
just multiply by 4, right? Because y is just going to be dy dt times
Wait, how did we
t.
even get 70?
Because we added up dA, dt, and dB dt.
Oh, true.
We added the velocities, right?
Okay.
Right. So y has to be the derivative of y times time, right? Which, this is fancy talk for saying 70 kilometers per hour times 4 hours, right?
Okay.
So what's y?
28 or 280. Wait.
Yeah, 280 kilometers. So now we know y. So we have y, dy, dt, and x. So we can find dz dt at 4.
Okay.
And that's it. And you plug in numbers. dz dt equals 280
Yeah.
times 70 over the square root of 150 squared plus 280 squared. Okay. Did you ever get your calculator?
No. Quite unfortunate, really.
Quite. It's your loss, not mine. I have a good calculator, and I know how to use it, so I'm not fretting one bit. What'd you get?
I'm still doing it. Wait, if there's 150 squared plus 280 squared, can you just get rid of the square root squares?
No.
I guess not. I'm gonna get this wrong, but
I don't think weed made you stupid.
whatever.
Maybe it did.
Okay.
Just don't smoke, man.
Error. Hold up.
Ish.
I don't know, man. One sec. Divided by
Ish.
150 squared.
Ish.
180 squared. Okay, I got 78,000.
No. 78. All right, what'd you get?
78,530.
So you're saying dz dt is 78,000. Does that make sense?
No, not really.
Because dz dt, it's a derivative of distance, right? So it's speed, right?
Yeah.
So you're saying that B is moving away from A at 78,000 kilometers per hour. Does that make sense logically?
No.
Right.
But I mean,
I'm not trying to belittle you. I'm just saying, when you're doing stuff like this, when you're doing physical problems, it's always great idea to check to see if what your answer is and if it makes sense, right?
Can you split the square roots in my calculator? So square root of 150 squared plus the square root of 280 squared?
No. You have to you have to square this whole thing.
When I do that, I just get syntax error, whatever the fuck that means.
I think you're doing something wrong. I don't know.
Yeah, you're probably right. I am probably being okay. I got 0.2495 when I tried it again.
0.2495. So now you're saying these things are moving apart at 0.24. So 0.2 is like what? 200 meters per hour.
Oh my god, I don't know, man.
Does that make sense? I'm asking you.
No, obviously not. Okay, listen. I did 280 times 70 in my calculator, okay? And that's
Okay.
like the ands thing or whatever, right? Then I
Okay.
divide that by, I press the square root button, okay? And then inside the square root, you do 150 squared plus 280 squared. Eh, Like,
You're trying to do too much in one step. Okay. So
okay,
what's 280? What's 280 times 70?
280 times 70 is 19,600.
19,600.
Yeah,
Now we have the square root of this. What's 150 squared?
it's
Okay.
22,500.
And what's 280 squared? all right.
78,400.
Add those two numbers.
156,800.
156,800. Take the square root of that.
I think I might have even gone. Wait. 22,500 plus 280 squared. I
100.
got it wrong. It's
Just
100,900. Sorry, it's 100,900 on the bottom.
not 156.
No, it's 100,900.
100,900. Okay. It's a funny looking number. What's the square root of that?
The square root of that?
Yeah. Why are you
It's,
so surprised? Why are you so
300
surprised?
317.647.
317.64, whatever. Now do 19,600.
600 divided by nth. I get 61.
So you get 61.7.
0.70.
And this is kilometers per hour. Does that make sense?
Yeah.
Does that seem
Yeah.
reasonable?
Yeah.
Yeah, that's your answer. Right?
So what even is that, by the way?
What is what?
The answer we got.
This shows. Okay, so when I said imagine you're in a car and another car goes past you,
Yep.
you always when you're looking at the car through your windshield, right? It doesn't look like it's going that fast at you, right? But then when you're right next to each other, right? It looks like it's going super fast, right?
Okay.
That's because when you're really close to each other, you're moving past each other really fast. And then once things are like further away from you, it doesn't look like they're moving as fast, right? So another example is, say you're outside, right?
Wait, sorry, Shane, I just need to clarify this before I forget something.
Okay.
X is 150 kilometers because that's what the question gave us, right?
Right.
So all we really needed to do was find what Y is, not in terms of kilometers per hour, but in terms of kilometer. And we found that using the fact that we had time is equal to 4 hours, right? So when you do 70 kilometers an hour times 4
Yeah.
hours, you cancel the hours out, and then you get a kilometer value.
Right.
And then if you do that, then wouldn't you just be able to find Z? Like,
Oh yeah, you can find
using
Z.
Pythagorean.
You can find Z, but you don't know you can't find the derivative of Z at the time, right? Because you have a fixed point, right? This is a fixed point. When I plug in 4 here, right? Okay, here's the thing. Okay, y equals dy dt times t, right?
Yeah.
All right, and x equals 150. Okay,
Yes,
so this is a different way you can do it. Actually, you can do it this way. You can say z. Okay, now we're gonna say z is equal to the square root of x squared plus y squared, right?
Yeah.
But now we know that y equals dy dt times t, right?
Right. Yeah.
Now, So now we can take the derivative with respect to t of dz dt. And if you do this, you should get the same thing. I'm not too sure though, because this is quite the disgusting function, right? And I really don't know what will happen when you take the derivative of that with respect to time. But
Okay, so this is actually a harder way to do it then.
it is a harder way to do it. But you're not wrong, right? So it's an interesting point that you bring up, because you can do it this way.
Okay.
But like I said, you'd have to figure out the derivative of that, which is a little bit tricky.
Okay. Question?
Wait, you didn't try any of these questions.
No, I did. Just got blocked.
Wait, you tried these and didn't get any of them?
No, not a single one. Anyways, suppose oil spills from a ruptured tanker and spreads in a circular pattern. If the radius of the oil spill increases at a constant rate of 2 meters per second, how fast is the area of the spill increasing when the radius is 65?
Galaxy,
What?
these questions are my favorite. This is called related rates.
Yeah, I know. We did a class on this shit. It says that you have to, like, to answer these kind of questions, you have to, what's it called? You have to, like, know what your relevant quantities are, and then you have to know what the known relationships are, and then you're looking for something.
Yep.
At something.
Alright, so what do you know? What do you know?
What do I know?
Mm-hmm.
Okay, well, I know that the, okay.
What do you know?
A circle,
You know three
circles-
things.
A circle's area is pi r squared.
Okay. Perfect. Great start.
And then the radius of the oil spill increases at a constant rate. So rate, that means derivative, right?
Okay.
So, I guess, fucking, I don't know how to write this out though, like that's the thing. Okay, never mind. So, I'm gonna list 3, so you have time. No, you don't even have time. The fuck am I saying? You have the radius, which is r. You have velocity.
Alright, stop.
What?
Read the question again. Out loud.
Suppose oil spills from a ruptured tank and spreads in a circular pattern.
Stop.
Yeah.
Right off the bat, you know you're dealing with circles. So you should automatically be thinking, okay, a equals pi r squared, circumference is 2 pi r, just think of circles. Have circles in your mind. And so when you said area equals pi r squared, great, perfect. That is exactly what you want to do. Keep going.
Okay, if the radius of the oil spill increases at a constant rate of 2 meters per second.
Stop. Okay, here's your next bit of information. It's giving you something. It's giving you
the radius.
No, it's not giving you the radius. It's saying the radius is increasing.
It's giving me the derivative of the radius.
Correct. Okay, so the derivative of the radius, dr d what?
That's the thing. I don't know if it's like...
So it's going to be time, right?
How do you know it's time, though? It doesn't say anything about time.
Because it's changing over time. It's changing, right? Imagine an oil spill.
Oh, it's the second.
Right, and you can think of it as the units, right? So the units are meters per second. So that's how you can think it's time. However...
Okay, so I'm going to write down on my paper that a is equal to pi r squared, right? Mm-hmm. And that dr dt is equal to...
Positive 2.
Yeah.
I want you to write positive 2 because it says the oil spill increases at 2 meters per second. You're going to have problems where it's going to be a negative. and you need to make sure you distinguish it between a positive and a negative, right?
Okay, so positive 2 meters per second. Then the next part, it's how fast is the area of the spill increasing when the
Stop.
radius is
How
okay.
fast? So how is a question, right? So they want you to
Yeah,
find
find something.
how
Yeah,
fast of the area of the spill increasing. Okay, so what does that mean? What are we finding in math terms?
the how fast is the area of the spill? The derivative of the area?
With respect to
Time.
time. So we're finding dA dt. Okay? And then the last part,
D capital A, right?
yep, d capital A dt.
Okay.
And then the last part, when the radius is 65
So R
meters,
is 65.
r equals 65. Okay. So perfect. So if we're trying to find dA dt, what do you think we should do?
Okay, pi r squared. Can you not just plug in 65 for
Nope,
r?
nope. Oh, yeah, sure. Go ahead, do that. What do you get?
Pi times 65 squared? I don't know what that is.
Okay, yeah. So that'll give you the area, right?
4,225 pi.
Cool. 4,200 whatever pi meters
Yeah.
squared. That gives you
Yep.
the area of the spill. Perfect. Awesome. Doesn't tell you how fast it's growing. We're trying to find dA dt.
Right.
What? So how do we do that?
Take the derivative of the area with respect to time.
Exactly. So dA dt equals ddt.
d of pi r squared.
Exactly. God. Right?
Okay.
No,
This
so let's do it.
product rule?
Why do you say
Wait.
product rule?
No, sorry. Pi is a constant.
Exactly. Perfect. Good call.
So I can take the pi out.
Yep.
Okay. So now I have pi d dt
Does this look
r
familiar?
squared. Yeah. Very.
It looks sort of like this, huh? Right? d dt of x squared.
Mhm.
Where we're taking the derivative with respect to time of a function squared. So what would this be?
You would get. Okay. So you would get pi, right?
Mm-hmm.
Times 2r, and then you'd have like you would have the derivative of r with respect to t, so it would just be
Exactly.
dr dt, no?
Exactly.
Okay.
So this is your answer. This is your answer for the general case, right? And now we just plug in numbers.
65.
Yep, plug in 65. Do we know what drdt is?
See, that's the thing. Like, it's just so convenient that it works out, but
What do you mean?
nah, like it just doesn't make sense. Like, what? So they give you dr dt, like, end of story, problem solved.
Yep.
That's
They're
how
easy.
most of these questions are gonna go.
Yep. They're all stupid easy. The first one was actually a little bit harder.
The first one was hard to think of a diagram to like
Right.
represent it.
It's hard to think of it physically, right?
Okay,
But
so anyway, so you have
wasn't impossible.
65 meters, and then you also have 2 meters per second. So wouldn't you have meters squared per second in the end?
Perfect. Yes. It's exactly what you want. Because
So
area.
I should draw I should write out the units then.
Right. So okay. So dA dt, right?
Mm-hmm.
This is change in area over change in time, right?
Okay.
Right. So area has meters squared, right? Units of meters squared, and time is
Yep.
second. So this should have units of meters squared per second.
Okay, so, all right. Pi. Do I write pi in my calculator?
I wouldn't.
Pi
Just
times.
because you can plug in pi on WebWork.
No, I can't.
Yeah, you can.
I don't have a key for pi on my keyboard.
Just type out pi, and it will
Okay, so
recognize.
it's 260 pi.
Right, so write that in. 260 times pi is your answer.
Well, 260 pi meters squared per second.
Right, but you don't need to put the units. There
Well,
you have it there for you.
in my notebook, I'm gonna put that.
Yeah. Good. Units will save you. Units are so helpful.
260 like this.
260. I'd put a times between it just in case. But I
This
think
is
that's
times, right?
Yep. But I think it would work either way.
Yep, that's right. Oh my god. Okay, question 2. If z squared is equal to x squared plus y squared, but z is greater than 0, dx dt is equal to 3, and dy dt is 5, find dz dt when x is 12 and y is 35.
Does this look familiar?
No.
Oh, you sure?
Oh. Wait, Pythagorean theorem?
Yeah. Didn't we just do this?
Yeah, but it's different. Like the question is weird.
Well, that's the thing. Look, that's the thing about math. We're just plugging numbers in, right? Right? So we did
So how do you
this.
go about this one?
Okay. Well, I'm not even going to do it, right? So dz dt. What's dz
You're
dt?
not gonna do it.
We already did it. Why waste my time doing it again? You wrote it down in your notes, right?
No, but that's not what the question is asking. It's not asking for you to do dz dt.
Yeah, it is. What is dz dt?
Then what's this part, Satan?
We're going to... Galaxy, take the derivative of z. We did this in question 1. Remember?
I don't remember, bro.
You fucking wrote it down!
So you're just gonna copy from question 1?
Why not?
Because it's not the same. You can't just be like, oh, I'm gonna take dz dt real quick. No, like now you have dx dt and you have dy dt.
Galaxy, what is the derivative of z with respect to t? Look at question 1 and give me the fucking answer.
It's 2x dx dt plus 2y dy dt over 2 times square root of x squared plus y squared.
Okay. Now plug your numbers in. I'll be back.
That's cheating, bro. That is cheating. God. I'm gonna fail my midterm, bro. Honestly. I don't know how the fuck I got 60%. What the shit? I studied too. It's just so, like, my eyes are tired, you know, like, my brain is not very big. How the fuck does this work? They just give you all the answers? Like, this is infuriating. And this dude is singing in the background. Whatever, man. I'm over it. 2 times 12.
Keep on turning.
Someone's having a party beside my room. Tomorrow I have work. Thank fuck my exam is in like a week and a half. Give me some time at least to like mentally prepare myself. You know. That's just so annoying how it's like, oh, I'm just gonna give you the answer. Like, hello? Like, there's no work here. You're straight up just, like... I don't get it, man. I can't be asked right now.
You get it?
How in the fuck do they just give you all the numbers?
Yeah.
I just, like...
You're overthinking it. It's not hard.
No, but, like, Is this implicit differentiation? Like, I really feel like this is just implicit differentiation.
Did you plug the numbers in, Galaxy?
I put it on a piece of paper.
I went to get a cup of water, and I'd hope you'd have plugged the numbers in and gotten me an answer by now.
Not in the calculator yet. I'm about to do that.
Okay.
I just like figured out what each thing is.
Okay. Okay. That works.
But again, like saying, it's just surprising to me that you can just do it that way.
It's surprising how fucking easy it is.
No, it's not easy, bro.
Okay, look, going from here to here is not easy, right? We went over it. When we went from taking from this step to this step, that was not easy.
How do you know to do that? How do you know to do that? How do you know that that's your first step? Like, that's the thing. All the math behind the shit is not hard. Like, I can do derivatives. I just can't. I don't understand where to go about it.
Here. Well, I'll set it up like this then. Alright. So for question 2, we had this. You know, I'm not going to write the units because I don't fucking care, right? We had this, right? And we wanted to find dA dt. And you knew right away, I'm going to take the derivative of this with respect to t, right?
Yeah, I knew how to do that right away.
Right. Okay. Well, now look at this one. How is this any different?
Because there's more dx's and dy's and shit.
I don't give a shit if there's 50 dx's and dy's. You know? Because, look, if it's asking me to find dz dt, I'm going to take the derivative of this with respect to t. Right? Luckily, we already did it in question 1, so it was a lot easier, right?
What if they asked you to find the derivative of dx over dt? How do you do that?
So if they told me to find dx dt, I would look at this and just say the answer is 3.
What if they told you to find the derivative of that?
Okay. So if they wanted me to find dx dt, right?
I have no idea what that is. But yeah.
Okay. If they wanted me to find this, right?
Yeah, like that.
I would do the derivative of 3 and it would be 0. Right?
Oh yeah, yeah. Okay. One quarter of the way. Spotlight on the ground is shining on a wall 16 meters away. Alright, can we do the thing that you were saying, like know and find?
Sure.
Okay, so a spotlight on the ground is shining on a wall 16 meters. What does that even mean?
I'd rather. Yeah, we can do know and find, but I'd really like to, when you have questions like this, it's really helpful to make a diagram.
To draw a diagram?
Right. But
okay, so how would you draw a diagram of this?
Okay, well it says, okay, spotlight on the ground is shining on a wall. Okay, so we have a spotlight on the ground, and it's shining at some wall. Okay, so here's the wall over here. Okay?
Okay, so this, okay, yeah. And then it says the wall is 16 meters away from the spotlight, so I can draw like a line there, right? From the dot to the bottom of the wall.
Okay. So this distance here. Alright. And also, by the way, this is on the ground, right?
Yep.
This light. So let's draw
so it's 16 meters.
Draw the ground like this, right? Or something like that.
I didn't do that. But okay, I just drew like a base.
Right, that's fine. Draw it however you want.
Okay, okay. So anyways, you have 16. All right. If a woman 2 meter tall walks from the spotlight towards the building at a speed of 0.8 meters per second, how fast is the length of her shadow on the building decreasing when she is 2 meters from the building? I'm gonna draw a woman 2 meters from the building.
No, she's not. Okay, yeah, okay. That's fine, that's fine.
Okay, so I draw a woman. She's 2 meters tall. And I'm gonna draw a line that goes from the spotlight to the top of her head and then to the top of the wall.
Perfect.
Wait. Oh, the top of the... I thought it was the top of the wall, but okay, fair enough.
No, okay, so it's a light, right? So light shines in all directions.
Right.
Like this. So if the girl's standing in front of it, there's going to be a shadow here.
Oh, and that's what we want to find?
Right. We're trying to find how fast is the length of her shadow. So we're trying to find this. dy dt. I don't really have a good like shadow color. dy dt, right?
Oh, so we don't even need to find the distance, really.
Not really. So this distance here is y, right?
Okay.
And we know she's 2 meters tall, right?
Yep.
And she's moving this direction, in the x direction, right? So here, let's start filling out.
Do the no thing. Yeah.
All right, so let's start filling this out. All right.
Okay, so we know first of all that the x dt is, what was it? 0.8 meters per second.
Okay. We know I'm gonna write height of the woman. I'm just gonna write height.
Your height, yeah, height.
Height is 2.
Okay.
We're trying to find y. No, we're trying to find dy dt, right? We're trying to find how this shadow is changing.
Wait, how fast is the length of her shadow on the building decreasing?
And she's 2 meters from the building.
How fast is the length of her shadow? No, but then wouldn't it be from the top of the wall to where the dotted line intersects the wall?
No, it's from the bottom of the wall. Because the shadow...
I don't really understand.
Well, that's just because of the question. It says, is the length of her shadow on the building decreasing? Because, right, so if you're really close to a source of light, you're going to have a big shadow behind you, right? Because you're covering up more of it, right?
Right.
So this girl, she's 2 meters tall, right?
Yeah.
If she was right here, this shadow would be this tall, right?
Okay, so everything... Wait, so then everything under that dotted line would be like black, essentially?
Yeah, everything. That's how big her shadow would be. She'd look huge, right?
Right.
And then it makes sense, right? Because in the same vein, if she was right up against the wall, right?
But the question is, how fast it's decreasing from.
I'm just explaining to you what it looks like, right? So as she's moving towards the wall, right? Yep. And once she gets to the wall, her shadow is the same height as her because she's against the wall, right?
Yeah.
That makes sense. Okay.
Yep.
Anyway, so back to the question.
Wait, no, but Sane. If you start at the yellow light, right? You start at the yellow light, and you're moving to where you have the 2 meters currently drawn, right? Your shadow is getting smaller and smaller until you get to where you are currently drawing. So that's what you want to find. That speed decreasing.
Right.
That's what the question is asking. So the y the dy dt you wrote is incorrect. That's not the right one. We're looking at from wherever it is at the top to where you are now.
No, but I didn't draw. You can't draw dy dt. This is a movement, right? I can't draw a movement, right? Okay. I'd have to make a GIF. I can't make a GIF.
No.
I drew y.
Is that, yeah, but you're saying dy dt is in that distance y, like that y is where we're gonna look at dy dt, right?
Yeah.
But that's not what I'm trying to.
What are we? When are we
Maybe I'm
looking at
wrong.
it?
I don't know. Maybe I'm not like
We're
explaining this right.
don't worry about it. We'll get to dy dt later, right? We're just going over what we know, right? We'll get to dy. We'll try to understand dy dt later. We're just trying to figure out what we know, right?
I'm telling you that's not the correct y. Is what I'm trying to say. It's not.
This is the correct y. This is the correct y. That's not even an argument.
How?
What do you mean? It's the fucking height of the shadow. It's the shadow. The shadow's this tall, right? Right?
Yeah.
I don't know how tall it is, but it's that tall, right? And like I said earlier, when she was this close, the shadow was huge, right? And as you get closer to the wall, it's shrinking. And it keeps shrinking until it gets down to
Okay, so are
2.
you saying that your starting point is where you drew the 2 and your ending point is the wall?
No, this is just some random point. I don't know where this is. This is just some random point. It doesn't matter where it is. Where I drew the girl is the pink line, is where she is. I don't know where she is in the line. It doesn't matter. Because all I know is that she is some distance away from the light, right? Which is the real important part. She's some distance away from the light. I don't know what it is, so I'm going to label it X. Okay?
No, you do know what it is.
What is it?
It's 14.
No. We're getting to that part. That's for later. But yes, you are right. We're measuring it at 14. But in general, right, if I want to look at it generally, it would just be X. It's some random distance X. Okay? Because if I look at it as just X, I can move it back and forth. If I look at it as 14, I can't move it because 14 is 14. Right? If I look at it as X could be 14. Or it can be 1. Or it can be 16. Or it can be 0, you know? By looking at it as X, I can move this girl around and I can get motion. And when I have motion, that's when I can solve for dy dt.
Okay, so L is 16.
So yeah, I just wrote the distance. I just labeled it L. You can.
Okay, right. So then what? So then you know your X. Then why are you not writing that there in the no category?
Okay, so yeah, we do know X, right? As 14, right?
Yep.
But remember, look back at your at problem 2. Remember, we knew what R was, but we didn't just plug R in immediately.
Right.
Right. So that's why I was kind of cautious about writing X equals 14, because X is a variable, okay? But we're gonna solve it when X is equal to 14. So this is sort of like a little. We're gonna use that later, okay? Now. We need to solve.
Like a similar triangles thing.
Mm-hmm. Exactly.
Sorry?
Exactly. So we have X over 2 equals 16 over Y. Right?
X over 2 is 16 over Y.
Right, so we have a triangle here.
No, I get it. Yeah, that's right. As long as you have your base on the numerator. Or like as long as you have the same values on your numerator and the denominator. Like they have to correspond to the same thing.
Exactly.
Yeah.
Exactly.
Okay. So X over 2 is 16 over Y. And now...
So this... Okay, so before we even got to this, I should have explained. Right? So we're trying to find dy dt, right?
Mm-hmm. Mm-hmm.
But we don't know what y is. So we need to get an expression of y. And what you said was using similar triangles. That's exactly what we have to do, because now we have an expression of y. So we solved this for y. And you will get...
your X is Y?
So solve this in terms of y. What happens when you solve this in terms of y? So I'm gonna flip both of them. Multiply by 16.
Okay.
See how I got this?
Yeah.
Okay. Now that we have an expression for y, we can take the derivative of it.
With respect to time?
With respect to time, exactly. So dy dt equals...
When you have y alone on one side,
Mm-hmm.
right? This is explicit differentiation. No?
Yes, it is explicit differentiation. But it's not in terms of the correct variable, right? So
because you started with you started with implicit, as in x is equal to 2 is 16 over y, and then you made it explicit by using algebra.
Yeah.
Is that one way to think about it?
But the thing is, we have x as a function of y, or we have y as a function of x, right?
Yep.
But now we're taking the derivative with respect to time, right?
So when you have d dt of y, you just drag the y into your dy? Like you just multiply, like the d multiplies with the y? It's like a fraction?
Okay.
That's the thing I'm kind of confused about too.
Yeah, so ddt, it's such a weird, or dd anything, right? It works so strangely, and it's kind of funny. It kind of, engineers and physicists use it like a fraction.
Okay.
So for example, the way we always think about it is, the best explanation is like position, right? So we have a position, right? S. We use position usually is S, but we can use X if you want, right? And so then velocity is change in X over change in time, right?
Yep.
But if we get this change really small, it becomes a differential. It becomes a differential change in X over differential change in time, right?
Okay.
And so that's where dx dt comes from. It's really just a fraction, right?
Okay.
Right? But it can also work as an operator, right? Like this, right? But if we add this, it can be written like this as well. But the same can be said for anything, really. We can have d dt of x squared. This can be written as dx squared.
No, it can't.
Yes, it can.
Because you have to do the chain rule.
Nope. It can be written like this. And then, from here, we can write this. Hold on. I'm thinking now.
If you had d dt of t, that would be 1, right? Just so I get that part right.
ddt of t would be 1. Yes,
Yeah.
exactly.
Because even if you did the fraction way, your t's and your d's would cancel each other out, and then you just get 1. No? Is that not how it works?
Yeah.
Okay, I'm thinking too much about this. Anyway, so dy...
No, but yeah, what you said is right. Yeah.
Okay.
It's kind of weird, but in the same sense, so I wouldn't think of it that way. But if you think of it like this, you can think of it as a differential change, like a small change in time over a small change in time. But don't think of this as that.
T, yeah, okay.
Right? Because it is still an operator, right? So
Yeah.
this is really, you can't really think of it like this, because it's not the same thing. Anyways, so I wouldn't in that case I wouldn't think of it as a fraction, but that is actually true, and that's sort of a small little proof of it, I guess you could say.
Anyways, when I have an independent variable, I guess it's safe to just multiply it by the d. If it's not like the one that we're differentiating by, like
Mm-hmm.
Okay, anyway, so you have dy dt is equal to d dt of 32 over x, correct?
Correct.
Oh, wow, okay.
Okay.
And this right here, well, I guess you have a quotient, or coefficient, right? 32.
32 is a coefficient. Correct. So
So
bring
do
it
you
out
even
here.
need to use the quotient rule here? Not really.
Not really. How else can we write this?
1 over x.
Try that.
Oh, you can do that.
Yeah. 1 over x is x to the negative 1.
Could I have done the quotient rule?
Mm-hmm.
Okay. Well, I
But
mean,
it's
it would
not
have given
fun.
me the same thing.
Yeah, but it's not fun.
Okay.
Right?
Yeah. Anyways, so you have x to the negative 1. Um.
And you
Okay,
gotta.
so the chain rule, right?
Mm-hmm.
So my outside is x to the negative 1. My inside is x. Sorry, my outside is
It's fine if you want to think of it that way, but
okay.
yeah.
Anyways, so okay. So you have x to the negative 1 times times dx over dt.
Yep.
Because the derivative of x is not 1. It's dx over dt when you're doing it in
Mm-hmm.
terms of t.
Correct.
Okay, I'm slowly getting the hang of this. But this is really the same thing that we did last week. It's just that now you're mixing word problems in. There's nothing that's changed really.
Exactly. Nothing new.
Okay. Okay.
Nothing new.
Is there anything new about derivatives that I haven't learned yet?
Partial derivatives. So like,
No idea what that is.
so here, let's say z equals x times y. There's something called the partial derivative of z with respect to x. What this means is you treat all other variables like constants, right? So if I take the partial derivative of xy, this is just y, right? Because you treat y like a constant, and then the derivative of x with respect to x is 1. That's the only thing you haven't learned is partial derivatives. But they're almost exactly the same as normal derivatives.
How did you get x squared, by the way? Sorry.
Because you subtract 1 from negative 1. Right? Subtract the power.
When you do the chain rule, you mean?
Well, right. So when you do the chain rule, you take the derivative of the outside function, right?
Yeah. So you would get negative x to the power of negative 2. No.
Yeah, exactly.
So how the fuck did you?
I brought it down.
Oh, because negative 32 from the negative x that goes to the negative 32, and then x to the power of negative 2 is the same as 1 over x squared.
Mm-hmm.
So you just do negative 32 over x squared times dx over dt, and I can't like simplify the x on the top and the bottom, right? There's no way for me to do that.
Nope.
Okay.
Think of it like this: if I have like 1 over x times sine x,
yep.
You can't like cancel out the x's, right? Because this is sine x. Think of d dt as like a function on the x, which it is. It's a function on the x. Right?
Well, I straight up forgot the question at this point, but I'm just gonna plug in numbers now.
We're trying to find dy dt, right? And so now is when you plug in your x equals 14.
Ah, okay. What would have happened if I did it at the start?
If you did it at the start, if you plugged it in here.
What if I said y is equal to 32 over 14, which it is, but...
Alright. Well, then you'd have a number. And if you took the derivative of that,
it would just get 0.
Right.
Okay. So it's like a trap I have to not fall into.
Yeah.
Okay. So dy dt is equal to negative 32 over x is 14. Square that. 14 squared. Dx over dt. What is that? Oh, it's the 0.8.
Yep.
meters per second. But then isn't x in meters?
Yep.
So when you do meters per second divided by meters, you get rid of the meters.
But you also have to think.
But then you have 1/second. That's kind of weird.
Well, remember, what is 32? 32 has units as well.
Oh, true.
Because remember,
30.
x, this is x meters over 2 meters, right? Right?
Yeah.
Equals 16 meters over y meters, right?
Yeah.
So this 32 is actually meters squared because it's 2 times 16. So it's 2 meters times 16 meters, which is 32
Right.
meters squared. So it cancels
Oh,
out.
fuck. Wait, I'm actually thankful this shit is not written, because if it was written, I'd have to remember units, but now they would just tell me in units, so I can just write the number down. Huh.
Mm-hmm.
Okay.
What'd you get?
Currently doing it on my shitty calculator. Give me a sec.
Alright. Take your time.
So, -32. Okay, so 196. So -32 times 0.8 divided by 196 is, Jesus, that's a very small number. -0.1306.
Yep, that's what I got.
That doesn't make any sense, but okay. Why is it negative?
Sorry you got twisted up in this scene.
Why is it negative?
Yeah, why is my answer negative?
Because it's shrinking. Y is shrinking. Right?
Okay.
So remember, you're this lady right here on this line on the ground. You're starting here. When I start here, my shadow is huge. It's massive, right? Because I'm right next to the light source.
Yeah.
As I'm walking away, it's starting to shrink down. It's starting to get reasonable.
Mm-hmm.
Then I get a little closer and I realize, okay, it's getting really small now until I even get to the wall. And now it's just the same height as the woman. Right?
Okay.
And so here, plug in when you get to the wall, yeah, never mind.
Yeah, it's just hard to understand why the Y that you drew is where it is.
You're measuring the height of the shadow.
But it's the shadow as you're decreasing, it says how fast is the length of her shadow on the building decreasing when she is 2 meters from the building.
Right. So
2 meters from the building is where you drew your pink line, correct?
No, it's not. Nope.
What?
I drew my pink line X meters away from the source.
Which is also just 2 meters away from the building.
Nope.
What do you mean, nope? X is 14, so yes, obviously,
the
pink line...
Remember I told you to beware that X equals 14?
No, I know. I'm just telling you, for the purpose of the question.
No, not even for the purpose of the question. X is X. It's a variable. You want it to be a variable so that it can move, right? Because it's a variable, I can move this line back and forth, right? Because X is a variable. If I say X equals 14, I can't move it, right? Because it's like 16 here, right? The light and the wall are 16 feet apart. I can't change that. They're always going to be 16 apart. I can't move the wall. I can't move the light, right? If I move the wall, I have to move the light with it, right? So if I want to move this, I can move the whole thing, but that distance is still going to be 16, right?
Okay.
But by saying that this is X, right, I can move it back and forth. And because I move it back and forth, the shadow changes depending on where X is. So I know that that Y is a function of X somehow, which we found here, right? Oops. Okay. Now, and so you use that to figure out what Y is, right? And then you can figure out what dy dt is. And then
So
it's asking you, all right, well, what's dy dt when x equals 14, right? And so now you're fixing x, wherever it may be. Okay?
yeah.
Let's go to the next one.
Yeah, yeah. Okay, anyways, answers in meters per second. Do I include the negative?
Hmm?
Do I include the
Yeah,
negative?
yes. Very important that you include the negative.
Incorrect.
Put more decimal places. I got 0, 6.
Yeah, 1, 2, 2, 4, 4. Answer should be positive.
Okay. So it just has it intrinsically in there, I guess. Whatever. Okay.
Whoa.
Brain weight as a function of body weight in fish.
This one is a baddie, honestly.
Oh yeah?
I can tell this one is gonna be a bitch.
Oh really?
Yeah. Brain weight B as a function of body weight W in fish has been modeled by... Okay, do we need to draw a diagram for this? I
Nope.
really hope we
No,
don't.
no,
Okay, so
no,
can
no.
we just go straight to know and find?
Yep, if I can find my stylus. There it is.
Okay, so brain weight B as a function of body weight W in fish has been modeled by the power function. B is equal to 0.007 W to the power 2 over 3, where B and W are measured in grams. Oh, okay. So the
They're
you see that.
weights.
So it's like a ratio of the weight, right?
Yep.
Okay. A model for body weight as a function of body length measured in centimeters is W is equal to 0.12 L to 0.53. What does that even mean? A model for body weight as a function of body length. But they're different. Weight is grams and length is length. How can you compare the two?
Doesn't matter.
Okay.
They're
If
related to
over-
each other.
Okay, yeah, sure. If over 10 million years, the average length of a certain species of fish evolved from 15 centimeters to 20 centimeters at a constant rate, how fast was the species brain growing when the average length was 18 centimeters? Oh my god. There are a lot of no's in this question. Okay, so alright, so I guess the first no is... Can we just write the equations like B and W?
Yep.
Okay. So B is equal to 0.007 W 2/3 and W is equal to 0.12 L 253. Okay, and then it says if over 10 million years the average length of a certain species of fish evolved from 15 centimeters to 20 centimeters at a constant rate. Okay, so time is 10 million, so I can just write 10. Right?
Okay, so let's slow down. Okay, so what did you say we know? So we know the two functions, right?
Yep.
Pretty black and white. So we have
Mm.
B equals 0.007 W 2/3, and we have
So can we say
W-
that T is 10? Because like let's say that our starting point is those functions or whatever, or is like 15 centimeters.
And is that 2.53 is the exponent?
It's 2.53, yeah.
Okay.
So T is 10, right? Please tell me T is 10.
It's 10 million. You were close though. I would have hoped to use 10, but look at how it wants the answer. It wants nanograms per year. So basically it wants you to do. So okay, so right. So you're saying T is 10 million or something, right?
Yeah, I mean, I guess
Yeah.
10 is a lot simpler to me, but yeah, sure,
I
2
agree. I completely agree, but unfortunately, here, trust me, you're gonna have to use 10 million.
Okay, so T is 10 million. The average length of a certain species of fish evolved from 15 centimeters to 20 centimeters
At a constant rate. It's very
at a
important that.
constant rate.
Okay, so let's stop there. So what is it saying? What's changing?
The length
The length. So what do we know?
that the what do you mean? What do we know?
Which is changing. So DLDT, right? We know
Yeah,
DLDT. What is it?
5.
Why is it 5?
20 minus 15.
So 20 minus 15. And
Yeah,
what are my units for that?
centimeters.
Centimeters.
Wait, I got that right?
But it's centimeters. It's just changing over time, right? So remember when I said
Dude,
remember when I
hold on,
said
hold
remember
on.
when I said we can think of this as a fraction?
Yeah.
You can think of it as a fraction here because it's a constant rate. So it'd be, you were right, 20 minus 15. But remember, we have a change in time as well. So what's our change in time?
I don't know.
Yeah, you do. What's your
10 million?
10 million? So I'm going to write this as 10 to the 7.
Wait, so it's not 5. The fuck?
Nope, it's 5 over 10 to the 7.
Nah, bro, no. There's
5
no way.
times 10 to
There's
the
not.
negative 7.
Sorry, Shane. He would not have done it this way. Because he wouldn't have told us to think of it as a fraction. So, is there a chain rule that I'm missing somewhere? Some shit
No,
like that.
you definitely think of it as a fraction.
So, how did you find dl over dt?
Change in L over change in time.
Bro,
Because it's at a constant rate.
is it at a constant rate?
Okay, here. Here's how maybe he would have taught you this, but he hasn't taught you anything properly, so I don't know. Alright, so at some time here at the start, right?
Yep.
0, we have 15. 15 centimeters, right?
Yep.
And then after 10 million years, right? These fish then grow to be 20 centimeters, right? So this is time over length, right?
Yep.
So then the distance between these, if it's a constant rate, it's a straight line, right?
Okay.
So then how do we find dLdt?
The slope, no?
Yeah, it's a slope. So what's the slope of this? Change in y, and our y value is L, over change in x.
Okay. In the student forums, they said this was like the hardest question, by the way.
No.
Well, maybe it's because of this step right here.
Maybe. Okay.
It's not intuitive at all.
Yeah, it is.
No, because so far we've been thinking of dLdt as like chain rule, but never as an actual fraction. You know what I mean?
Okay, that's fair enough.
Anyway,
So-
so you have 10 to the 7. So can I just leave it that way? 5 over, or like 5 times 10 to the...
You can do 5 over 10 to the 7 or 5 times 10 to the negative 7. Either one works.
Okay, so
Huh?
we know dLdt. Cool. Now, how fast was the species brain growing when the average length was 18 centimeters?
So what are we trying to find?
How fast was the species brain growing when the average length was 18 centimeters? So we're trying to find dB over dt?
Perfect. dB over dt.
Yeah.
Okay. Okay.
Find
When? Okay, so when
find
what?
dB. Okay, yeah. So find dB over dt um, uh, when dLdt is 18, or wait, hold up. So we need to. Oh, dude, I actually don't know.
Okay, so we're trying to. You're right. You were trying to find dBdt, how
Yep.
fast the species brain is growing,
Hmm.
when the average length was 18 centimeters.
Okay.
So, what equals 18 centimeters?
The average length.
So is that L or dLdt?
dLdt.
Why is that?
Because that's what we calculated. 5 times 10 to the negative 7. That's like.
No, but
Uh,
okay, you're looking at the sentence. If over 10 million years, the average length of a certain species of fish evolved from 15 to 20. So, and change that, switch out the word evolved with changed. The average length changed from 15 to 20. Right? So,
okay.
that first part is the LDT because you're changing from 15 to 20 over 10 million years, right? Here it's just saying the average length is 18 centimeters.
Okay.
Right? So it's just saying L equals
18.
18 centimeters.
So find dBdt at L.
And again, I
18
put it in.
centimeters.
I put it in centimeters, but I put it in a dotted box because we're not.
Oh, right.
We're gonna
Right.
evaluate
Yeah,
it later.
later. Okay. Okay.
All right. So here, what do you think we should do?
Find dB over dt.
There's two ways to do this. You can straight up plug in. Right. So you want to take the derivative, right? What are we taking the derivative of?
Like, see, that's the thing. Like, what? Like, I don't know.
What's b? We're taking the derivative of b, right?
Yeah, we are taking the derivative of b.
What's b?
0.007 W.
Exactly.
What the fuck is the rest of the shit for?
Well, that's the thing. There's two ways to do it. You can take the derivative of this, right?
Yeah.
Let's do it this way. Okay, so take the derivative of this.
Okay, hold on. d dt of 0.007 W thirds close brackets. The derivative of that? Okay, so, I guess you can product rule.
Nope.
Wait, 0.007 is a what's it called? Coefficient?
Yep. Okay,
So
let's
can I just take it out?
Exactly.
Okay, and then, chain rule here.
Chain rule.
Why do you have a negative 2 over 3 years?
Oh, sorry, because I already took the derivative in my head and was screwing
Okay.
it up. Okay.
So, alright, so, sorry in advance, but my outside is W, 2 over 3.
Okay.
My inside is just W. So I would have 2 over 3 W, well, you would have 0.007, right? Times 2 over 3 W. What is 2 over 3 minus 1?
You tell me.
That's negative. Oh god, negative 1 over 3.
Perfect.
Okay, hold on. Oh my god. So 2 over 3 W times W to the power of -1 over 3, and then times the derivative of W with respect to t times dw over dt. Yep. Yep.
So is this what you got?
That is exactly what I got. Yep. And I actually understood it. So yes.
Perfect. Okay. Now. Okay. Do we know what W is?
We do know what W is.
Okay, perfect. So what's W?
Fucking, I hate these decimals, dude.
I'll get rid of them.
So dB t equal to 0.0072 over 3 times W, which is that 0.12 L. Is that 2.53? Yeah, it is. That's 3. Times another W.
Alright. Slow down. Slow down a little bit.
Am I not doing this right?
Where are you? Are you watching my screen?
No.
Where are we at right now?
I'm writing dB over dt is 0.007 times 2 over 3 W, right? And my W, I plugged in the decimal value of W.
Wait, well, look at my screen. Is this what you got for DB?
Yeah.
This is what you got?
Yes. But I'm plugging in W because I have it. So now
I thought I'm hearing you say it, and I'm hearing you say an extra W. You're saying
yeah,
like
there's two W's.
no. There's one W, and then there's dWdt.
Bro, there's two W's.
No. Oh, you take the
So
derivative.
I got it wrong. Wait, I actually got it wrong.
I asked you if we got the same thing, and you said yep.
What did I fuck up? The chain rule of the outside part. Oh, I fucked that up. 2 over 3 W times W to the power of -1 over 3.
No, it's just 2/3.
Oh, it's just 2 over 3.
Yeah.
You don't. Oh.
Because it's you bring down the
See,
exponent.
that's just a 1230 mistake. Nothing more, nothing less.
Well, I'm glad it's that.
Yeah. Anyways, so dB dt is 0.007 times 2 over 3. And I still have the W, which is 0.12 L, 2.53. But I don't have two of them, except one of them. And then I times all that by dW over dt. Now, what is dW over dt?
How can we find that?
Take the derivative of W with respect to time?
Exactly.
Actually?
So now we do dW dt equals ddt of what?
Of W.
What's W?
0.12 L, 2.53. I have no idea what you wrote, but okay.
I wrote that. What do you mean?
No, like the 14 over 3,000. I don't know for that.
That's 0.007 times 2/3.
Yeah, I don't know.
That's just, oh my god, Galaxy, that's Algebra 1. No, it's not even, that's like, oh. Anyways, let's get back to calculus. Jesus Christ. Okay.
Oh my god, Stan. Anyways. dW dt. People are partying outside, by the way.
Okay. Do you want to go party?
No, God, no.
Okay. So you want to do this?
I'm trying to grind this math. I'm trying to do this shit.
You get it yet? Come on, let's go.
Sorry.
So
0.12. Drag that outside.
Drag that.
Drag that.
Dragmanting.
Then you have 0.12 times 2.53. What you doing? Well, it's 2.53 L, 1.53 times dL over dt.
Perfect.
Oh, I'm crazy with it. I'm actually a machine now. Holy. 0.2. Inside, outside. Inside, outside.
Okay, so now we know
I
what
have no more
DWDT is. You're one to talk. I got nothing.
Okay. God, this question is killing my head, bro. Oh my god, if this shit ever comes up on the exam, JJ, automatically.
It's not even hard, man.
What? What? Dude, we have to take the chain rule, the chain rule, the chain rule. That is very hard.
You didn't. You just had to take the derivative of two things. You're just overreacting, man.
Not everyone is like a Purdue, Harvard, MIT graduate like you, okay?
Well, maybe they should be. Alright.
Hello?
What?
Ooh, 0.3036? What is that?
I combined the exponents here. Or not the exponents, the coefficient.
Ah, okay, I see. You like to skip steps.
It's easy shit, man.
Anyways, DLDT is 5 times 10 to the negative 7, so you can plug that in, right?
What is that? Yeah. Yeah, DLDT and then L.
L is 18, so you can plug that in as well.
Mm-hmm.
So then I'm just gonna find the answer.
Yep.
Right?
Correct.
Crazy question. So 14 and 0.12 times 18 to the power of 2. I'm gonna need your calculator. If I try this shit on my calculator, like, no chance. I got the right equation though. I just know that I'm not gonna. I'm gonna try it out. I'm gonna see what happens.
Yeah, I haven't even solved it yet, so.
Syntax error. Let's go. I'm at 3,000.
Remember to just, you know,
For the what?
use your algebra skills to make things easier for you.
Not sure you could make this one easier, to be honest. Oh, I didn't get a syntax error this time. Oh, I may have gotten an answer.
Okay.
1 point. Hello?
Hold on. This one is a real bitch.
Agreed. By the way, that's what we're trying to find, right? DBDT?
Mm-hmm.
It's nanograms per year. I still don't know what that means. I don't even know what a nanogram is. The fuck? How the fuck did you get 2? Satan,
Yeah.
I got 1.2743 times 10 to the negative 7.
I don't know. I don't know how you got that. Nano is 10 to the 9. 10 to the negative 9.
Wait, yours is not right?
No, I'm trying to figure out. 1, 2, 3. Try 2,294.
No.
Alright. So this was one way to solve it. We're gonna try to solve it the other way.
There's another way.
Yeah. I think this way is easier. Okay. So B is a function of W, right?
Mm-hmm.
But W is a function of L, right?
Okay.
So what if I just say B is equal to 0.007, 0.12 L to the 2.53 to the 2/3? Right?
Yeah.
I could do it this way, right?
Yeah.
So now, oh, I know what I did. I forgot to raise shit to the exponent. I forgot to raise some of the terms to the exponents. I think. I really don't know, to be honest. This is sort of just a math hell kind of question. So now, so just do some algebra here. Okay. Now
Sorry?
I take the derivative with respect to time.
Oh, that is a lot easier, actually.
Yeah,
Because you just have to do it once. You don't have to do like a bunch of different derivatives.
exactly.
But the way I did it is more, what's it called? Complete. You know what I mean?
Yeah.
Like I'm not really using any shortcuts. I'm just kind of using what I know to find what I want to find, right?
They're not, you don't have to think of it as a shortcut.
Well, it's not really a shortcut. It's just the way that you did it is very original. Like you kind of have to be creative to figure that out.
I guess.
So.
You could think of it as creative.
Well, yeah, like I wouldn't have guessed to think of it as like like a f of g of L. Like there's no way that I would have. Dude, to think that like a couple months ago I didn't know what f of x meant. Good God.
Good God.
Okay. Stan?
Mm-hmm.
I think that for both you and I's sake, let's try to end at problem 7 tonight, because it's due tomorrow, so I still got time. Yes? No? Hello?
I'm trying to figure out this question.
Oh, okay, yeah.
All right. Here's your answer.
Cool.
This isn't it. We're skipping. So yeah, algebra. Algebra's a bitch. I'll come back to haunt you. You did all.
That was just calculator work.
Yeah. Which is algebra, really. Your calculator just does
Right.
algebra for you.
Oh, question about ducks. Let's go. Oh, dock. Never mind. I got excited. I saw duck. boat is pulled into a dock. A boat is pulled into a dock by a rope attached to the bow of the boat and passing
Bow.
through a bow. This shit was in French. To the bow of the boat and passing through a pulley on the dock that is 1 meter higher than the bow of the boat. If the rope is pulled in at a rate of 1.2 meters per second, how fast is the boat approaching the dock when it is 8 meters from the dock? Okay, so this is definitely a diagram question. I can just tell.
Good call.
So we should draw a diagram.
Good call.
Okay, I don't know what a bow is, and I'm not sure what they mean by pulley. So
You don't know what a pulley is?
I
The bow is the point on the. Think of the bow as the point on the boat. Really doesn't really matter.
Okay, I'm pretty sure I know what a pulley is.
All right.
Have a boat.
We're getting pulled in.
We're getting pulled in by a pulley.
Now we're
Okay.
told that this dock.
A meter higher than the peak of the bow. Okay. And then what's the next bit of information?
The rope is being pulled in at a
Pulled in
rate.
at a rate of. How fast is the boat approaching the dock when it is 8 meters from the dock? Okay, so I guess the base of this triangle is 8 meters.
But there you go
It doesn't
again.
really matter right now. That doesn't really matter.
Right. Okay. So
I'm just saying,
the
like,
base-
just to draw it out.
The base of this is X,
Okay, this is X, this is
And-
Y,
and this is Z. Okay.
and this is Z. So, yeah, okay.
And this is gonna look really familiar. Z
Yeah.
squared.
Hella familiar. X squared plus Y squared.
Exactly. Now,
Okay.
what are we trying to find?
Okay. Well, first can we start with what we know, actually? Because
Yeah.
it says if the rope is pulled in at a rate of 1.2 meters per second,
Okay. Okay. Perfect. So what does that mean?
that is dx over dt, no?
Which one? Okay. Which one of these lines is the rope?
Oh, that's dz over dt.
Right. dz over dt.
Okay.
And
So-
what is it?
It is 1.2 meters per second.
So it's 1.2, but it's shrinking, right? So this should be negative 1.12.
Sorry?
This should be negative 1.2 because this is shrinking, right? Because if I'm pulling this thing in, if I'm pulling on the rope is
Yep.
getting smaller, right?
Does that matter?
It should. We're gonna
No,
find.
no, I'm just saying that, like, does it, like, on the exam, will it matter if I remember my negative or positive?
I don't know. I'm not taking your exam, but yes, you should think of this as a negative value. Yes.
Okay. Alright, so I'm just gonna write negative 1.2 meters per second.
Okay. So we know that. What else do we know? Look before if the rope is pulled.
Well, isn't the height never gonna change? Like, y is always gonna be a meter higher.
All right. So perfect. So you just found out two things. What did you find out?
I straight up don't know. I just said that y is a meter higher than the top of the boat.
Okay. So y is 1, right? Y is 1 meter.
Yeah.
And you said something else. You asked a question. What was your question? I don't know
Well,
if it was rhetorical or not. What was the first thing out of your
I just
mouth?
said that y is always gonna be like a meter higher than the bow of
It's
the boat.
always the same, right?
Yeah, it's like constant.
So what does that tell us? It tells us something else.
I don't know. dy dt is 0?
Exactly.
Wait, actually?
Yeah. Because it's not changing. That height isn't changing at all, right? Okay.
That's actually a tough one, saying, I ain't gonna lie.
Now what are we trying to find?
you write 0 meters per second, right?
Yeah, you can write that if you want.
So dy dt is 0 meters per second, and y is 1 meter. And we're trying to find how fast is the boat approaching. Oh shit, that's dx over dt.
Yeah, we're trying to find.
Trying to find dx over dt. Find dx over dt.
When
But,
x equals 8.
right, at x equals 8. Okay,
Okay.
but that doesn't matter. I have to remember, that shit does not matter right now.
Right, that's when we come in at the end.
Yeah.
Right, so here's our equation
Okay.
again, right?
Yep. Here, let me try this real quick. So if x's are right, the adjacent side, right, then it's z squared minus y squared, z squared minus y squared, right?
Mm-hmm. So x squared equals z squared minus y squared. Perfect. Then
X
take the
squared
square
equals
root.
z squared minus y squared. So x is the square root of that,
Perfect.
right?
Mm-hmm.
Now we have to take the derivative of that. With,
Exactly.
like, what's it called? With respect, right? With
Right.
respect to t.
Mm-hmm.
So you write it by saying d over dt, and then you do the square bracket things. Square root of z squared minus y squared, right?
Yep.
Okay. Chain rule?
Chain rule.
Okay. So my outside in this case is the... What is my outside? What is my outside? Square root
Your outside
of...
is going to be the square root. Yep.
Square root of, you know, the thing.
The thing.
That shall not be
the
mentioned.
ting. Yeah, it looks like square root of x, right? Your outside function is square root of x. Right?
Yeah.
Square root of theta, square root of smiley face, square root of whatever.
You hate it when I say square root of z squared minus y squared. You
Yeah.
it's not.
Cause
Okay.
No, cause it's not. That's the whole function. Right. But anyways. Continue.
So it's the derivative of that? I'm getting confused here. The derivative of the outside. Okay, so my outside is square root of x. And the derivative of that is 1/2 x to the power of negative 1/2. Right? But
Yep.
now you put the inside. And the inside is z squared minus y squared. So I substitute that x with z squared minus y squared. So in the end, I'm going to get 1/2, right? Times z squared minus y squared, right? To the power of negative 1/2. And then the derivative of z squared minus y squared with respect to t.
Yep.
I don't know what that is, to be honest with you. Is that another chain rule?
Yep, we have to do chain rule again.
Oh my god.
This one's easy.
Shish kebab.
Look, it's
I'm not even on your stream right now.
It's gonna be ddt of z squared minus ddt of y squared, right?
Oh right, you can do that thing again.
And we've done these before. We've done these multiple times. Right?
Right.
Forgot
No,
my
we
one.
have not really.
Yeah, we did it for r squared, we did it for x squared.
No, we did it for when it was just y alone, not when there's a square.
Remember we did dA dt of
Oh shit, you're right, we did. No, we did, yeah. But I already forgot.
Good thing you have your notes.
Well, I have them. Don't really look at them. But okay, so anyways, I'm gonna try to not look at my notes when I'm doing this so I can see if I can do it again.
Okay.
So, my outside in this case would be... What is my outside? I guess it's x squared.
Sure.
So then my inside is just z.
Mm-hmm.
Okay, so you have 2z 2z times dz over dt, because that's
Perfect.
the derivative of the inside.
Yep.
Now I don't even have to calculate the second part. I could just like automatically just be like
It's the same thing.
minus 2y times dy over dt, correct?
Exactly.
Beast mode. Okay. And now plug them numbers in.
Yeah. And here, you want to know something?
Wait, no, we're fucked.
Why?
Because um because we don't know what like x or y are. Wait, yes we do. Y is 1 and x is the square root of z squared minus y squared.
Exactly.
No, but this is going to be a long ass equation, fam.
Okay, you looking at my screen?
Now I am. Yeah.
Okay, so I did something here. If you take the derivative with respect to time, you can put a dot over it, right? So you know how you have a dy dx? You can write it as
Yep.
y prime like that?
Yeah, I sometimes do that, yeah.
Yes. Well, if you have dy dt, people write this as y dot, and they put a dot over it. Only if it's with respect to time. Because writing this out is kind of a pain, to be honest. Right? And so here was my equation here, right? Z dz dt minus y dy dt over the square root of z squared minus y squared, right?
Yeah.
Okay. So now we need to know what all these are, right? Do we know what y is?
Wait, no, see, I'm fucking confused by the thing you did with the dot or whatever.
Okay. You gotta really work on not getting confused by notation. Because notation is the easy part.
Mm-hmm.
That's okay.
Sorry.
You're fine. Don't worry about it.
Okay, so...
Alright, so
Wait, you missed something.
the twos, all the twos that all cancel,
Yeah.
they all cancel.
They all cancel?
Yeah, you have two twos in the numerator,
Oh,
right?
yeah,
And you
true.
wanna...
True.
Okay. So, do we know what y is?
Sorry. dx over dt is equal to z. I'm sorry for being slow. Honestly,
You're
I'm
fine.
trying to understand this shit. Minus y dy over dt, correct? Now, where did you get the... Oh, because it's just divided. Because it's 1 over, right?
Mm-hmm.
Okay. Square root. Square root. Oh. Z squared minus y squared. Yeah, we know y. Y is 1.
Okay, y is 1.
Mm-hmm.
Do we know dy dt?
Yep.
What's that?
Dy... Wait, do we know dy? Yeah, it's 0.
0.
Uh-huh.
Perfect, so this whole term just goes away,
Oh,
right?
dude, this shit happened last time as well.
Yep.
Like something went
And
away.
we know what dz dt is, right?
Yeah, that's negative 1.2.
Negative 1.2.
Uh-huh.
And now, do we know
what
what
z is, though?
We do, right? Because z is defined as the square root
Oh,
of x
true.
squared, plus y squared, right? Alright?
Yeah.
And so then this equals x is 8, so this is 64 plus 1. Right?
Yeah. Okay, so you get square root of 65 times dz over dt times negative 1.2, right?
Mhm.
over the square root of z squared, which is just 65, no?
Z squared is going to be 65, right? Exactly.
Yeah, that's what I just said, yeah. So it's the square root of 65 minus y squared is 1 minus 1.
Mm-hmm.
So it's 64. So it's the square root of 65 times negative 1.2, right?
Mm-hmm.
Over the square root of 64.
Well, here, look at this. You want to see something cool?
Sure.
See this right here?
Yep. Oh, true.
So what if I wrote this like this?
That would be pretty big brained.
That's a lot easier, right?
What even is x though?
X is the square root of z squared minus y
No,
squared.
I know, but in terms of a number, like you can't really plug any number in for that, can you? Oh shit, yeah you can. Is square root of 65 times negative 1.2 over square root of 64 gonna give me the same answer?
Yes.
Okay, let's test that theory out.
If you did all the algebra correctly, you should get the exact same answer.
I 100% did all the algebra correctly. Have you ever seen me mess up algebra?
No, never. You're man them with the algebra.
Okay, so I got negative 1.2093. That should be right. Oh god, if this isn't right, I'm gonna just leave.
Okay, so it should be negative, but if it's not, just make it positive. Okay.
What?
Just make it positive.
Oh, just okay. Like, but how though?
That's fine. Just don't worry about it.
No, I should worry. Dude, of course I need to worry about this.
Okay, look.
Hello?
Look at this x value, right?
Yeah.
As I get closer to the dock, that x
It
value
decreases.
shrinks, right? That's why the rate
Correct.
is negative.
Correct.
But it says how fast is the boat approaching the dock. So when it says how fast it's approaching, it automatically has the negative sign in the question. So your answer is going to be positive. It's
Whatever.
so if you're approaching someone at a negative speed, you're going
Yeah.
away from them, right? It's
Yeah.
like a double negative. So, but
Yeah, it's just like it's hard. Yeah. No, I see where you're coming from. Okay. Oh god. This is the last one because I actually have to sleep. You do too.
I know I do.
Tomorrow you got work.
Tomorrow's Saturday
Yeah, work on O-dubs. Grind.
on the grind. Okay, so
Particle is moving along the curve y is equal to square root of x. As the particle passes through the point 4,2, its x coordinate increases at a rate of 3 centimeters per second.
All
How
right.
fast is the distance from the particle to the origin changing at this instant? Okay, no diagram needed.
Correct.
What do we know?
Tell
We
me.
know the equation.
What is it?
Y is equal to square root of x.
Okay. What else
We
do we know?
know... Sorry?
What else do we know?
Okay, we know the point 4,2.
What is that?
That's
Dissect
like the
that.
point where I'm gonna find the derivative.
Okay, so dissect that for me.
Dissect it.
Mm-hmm.
What do you mean?
Dissect it for me.
Oh, are you trolling me?
No. What does 4-2 mean?
X is 4 and Y is
Okay.
2.
X equals 4, Y equals 2. Perfect. That's all I wanted. All right, what else do we know?
I'm writing this down. Its x coordinate increases at a rate of 3 centimeters per second.
Uh-huh.
dx over dt.
This is probably the hardest question, by the way.
dx over dt, no?
Yep. And what does that equal?
3 centimeters per second.
Okay. And what are we trying to find? This is the hard part.
How fast is the distance from the particle to the origin changing at this instant? How fast is the distance from the particle to the so it starts at the origin
Mm-hmm.
and it's going to 4-2.
Right, so it's following this curve.
Yeah.
Okay.
How fast is the distance from the particle to the origin changing at this instant?
So here's what the curve looks like.
Oh, I'm on your stream now, yeah.
Okay? And it's trying to find, it's asking for how fast is this distance changing at at 0.42, but at any general point, x, y, this is some distance r, right? So it's trying to find how fast is this distance changing. So we're trying to find dr dt. Ooh, spooky, right?
That made no sense.
How fast is the... Okay, so forget the how fast is the... Let's start at distance from the particle to the origin. So the
Okay.
distance from the particle, so let's say the particle is right here, to the origin.
Yeah.
So the distance is a straight line, right?
Okay, and you're calling that line R.
Right.
Okay.
And so now I was saying, how fast is this distance changing?
So that's the velocity. So dr over dt. Yeah, you're right.
Okay.
Well, I guess it's d over dt of r.
Yeah, you can write it that way.
Okay.
It's the same thing. They mean the same
Yeah,
thing.
no, I know. It's just because like you're trying to take the derivative of the distance, with respect to t.
Mm-hmm.
Okay.
Now.
Fine.
Okay. Let me know when you're ready.
Find dr over dt. Yep, got it.
So we need to take the derivative of r. What the hell's r?
That's the thing though. Like, it's a secant line.
R is?
Yep.
Okay. Here, let me help you out here.
Oh, triangle.
Ah.
True. So you do need a diagram. The fuck?
Yeah, it helps.
You just said okay.
I can draw a straight line. Anyways. You see it. Alright? So what's r?
Yeah. No.
What does r equal?
R is x squared plus y squared.
Square root. Right?
Yep. Yep. So that's the clever shit that I would not figure out. But
Okay.
yes.
About to get even more clever. Ooh.
Wait, no. You just
Yeah.
do the derivative. Stop.
Nope.
Just do the
No,
derivative.
fuck that. I'm not taking the damn derivative of this shit.
Why?
Don't want to.
But that's how you find the answer. What do you mean?
What is y?
Y is 2.
Nope. What is y?
Y is square root of x. Okay.
Now we take the derivative.
I mean, it doesn't really change anything. You're still doing
Oh,
it. in
okay,
terms of
so
t.
so let's think about this. If I were to take the derivative of this, I'd have a dy dt term in here, right?
Correct.
Do I know what dy dt is?
And no.
No. So that'd
But you could figure
be...
it out. You could figure it out.
Yeah, you're right. I could figure it out. What you do is you'd have to do dy dt equals d dt of square root x. This would be 1 over 2 root x dx dt.
Wait, why square root x?
Because that's what y is.
Oh, true. Yeah.
Right? So dy dt equals 1 over 2 root x dx dt. I'm not explaining this because this is not something I would have wanted you to do. Right?
Mm-hmm.
And now we plug in x equals 4 and dx dt equals 3. So this is going to be 3 over 4.
Yeah, so you're chilling. You can still do it the original way, right?
Yeah,
What
you can't do it this way, right? But look at all this work I had to do. I take another derivative, I have to plug shit in. That's a pain in the ass,
Right. But seeing,
Yeah?
what I'm trying to say is that, like, the r is equal to square root x squared plus y squared. You're still taking the derivative of r in with respect to t, right?
Correct. So
you're always gonna have to substitute something in.
right. But I have to substitute in less if I do it this way.
Yep, you're absolutely correct. X squared plus square root of x squared. Dude, what the you're like smart. What the shit? Anyways.
Yep.
How did you... Oh, no, got it. X squared plus x. Okay. So I have on my paper r is equal to square root of x squared plus x. Now I take the derivative. The derivative of that.
Correct.
So dr dt is equal to d dt of square root of x squared plus x. Chain rule? Yep. The outside is square root of a. And then you put the... Well, no, hold up. Think of it as to the power of 1/2. Okay, yeah. So it's 1/2 x squared plus x to the power of negative 1/2. And then I have to take the derivative of the inside.
Mm-hmm.
What is d dt of x squared? Well, that is just 2x. Huh?
Yeah. Keep going.
Yeah. 2x times dx over dt, I believe.
Perfect.
And then I multiply that. Or do I add that?
You add.
Add that. Add that to dx over dt. Right?
Yeah.
Now my question is, Satan,
Yeah.
when I multiply the first term by the addition thing, can I put the addition thing in brackets so that distributes?
Yeah. I think it's hard to understand.
Well, okay, so
To
what I
visualize.
have written so far is 1/2 x squared plus x to the power of negative 1/2, right? That's like the
Correct.
first term.
Correct.
That's like the outside derivative,
Mhm.
right? And then it's times 2x dx over dt plus dx over dt.
Mm-hmm.
Okay.
Then you can
my question
factor
is-
out a dx over dt.
Right. But so it is in brackets then. Okay, yeah, no, I'm good. Sorry, I was just wondering
Yeah.
if it was in brackets or not. So I have 1/2 x squared plus x to the power of negative 1/2, and then I factor out, like you said, a dx over dt, which times 2x plus 1, right?
Mm-hmm. 16 plus 4 is 20.
This is where it gets tricky though. Because now I have to. Now I have to start thinking about how I'm gonna do. I guess I could just plug numbers in, dude. Like, what the fuck am I trying to do right now? There's no way to simplify this further.
What'd you get? This is what I got here.
No, you can't simplify it further.
This is what I
just don't
got.
know. I don't know how to go from -1/2, like, to the power, right? Power of -1/2. Like, what do I do with that, right? Because x squared plus x to the power of -1/2. Like, what is that?
You just read this number.
But what is it?
Are you asking me like what the value is, or like what does it look like? You're saying
X squared plus x to the power of -1/2. What is it?
x squared plus x to the power of -1/2.
Yeah.
You can write this as 1 over the square root of x squared plus x. It's the same thing.
Okay, so then. Okay, sure. I guess so.
I know so. I don't guess so. Now I'm just checking.
2x plus 1 over 2 times the square root of x squared x. And then I times all that by dx over dt, which is the factor part. Okay, and now I can plug numbers in finally. Okay, 2x plus 1. By the way, we're finding dr dt at 4-2 or 2-4, whatever it is, right?
Yep. 4-2. So what I did here was, remember when we said x squared plus y squared square root, and then we transitioned to be just x? Remember when we did that
Yeah.
a couple minutes ago?
Yep.
You can take the derivative of this, and you'll get this function here, right? So let me put it in blue or something. Right? But now this is in terms of x, y, dx dt, dy dt, right?
Yeah, I mean, I don't even know where you got the y from.
Well, I got it from this equation. When I take the derivative of this, right?
No, I know. I'm just saying from the left green part to the right green part. How did you get y? But
I'm just saying these are equal. I'm just saying these are equal.
oh, they don't have any relation to each other, though.
No.
Okay.
This is the
so you
derivative.
just get it in your head, like, really quickly.
Yeah. And then this, well, I don't want to do it in blue, but, this is the same thing as this one, right?
Yeah.
But they're both the derivatives of r with respect to time, so they should be equal. They should be. And so I plugged in numbers to check, and they do in fact equal the same thing. And by the way, this is your answer, by the way.
Well, I have to plug in numbers still.
Yeah. Well, let me know what you get.
So 2x plus 1. This is 4. 8 plus 1 is 9 over 2 times x squared. 4 plus 2 is 6, so 2 times root 6. Dx over dt, we don't know what that is, so we have to figure that out. Oh no, we do. Yeah, we do know what that is. Wait, how do we even find dx over dt? The fuck?
How did we find it?
Yeah, how did we know dx over dt is 3?
Look in the question.
Oh. Yeah. Never mind. Dumb question. Silly question.
Silly man.
Silly man. Waste man. So I get 27 over 2 root 6.
Root 6. Incorrect.
X squared
Is
4.
Nope.
Oh, I'm a silly one, aren't I?
Bad one. You're on a
16 plus 4 is just 20.
Correct. Now we're talking.
2 root 20. I'm not even gonna bother putting that shit in my calculator. Oh god, what is that? It's like a
Bottom
weird
right.
thing on my deck.
Bottom right. Bottom right for Cheese World.
3.018. Watch it be negative this time. That'd be hilarious.
Nah, not negative. Scrap landings.
Oh, they skipped 9. Okay,
Ooh,
tomorrow. What the shit?
Ooh.
GG to
That
this
one.
one.
That one looks fun.
This one is a GG as well.
No, that one looks easy.
This one is easy. No.
No, that looks easy.
Oh, GG.
That looks easy as well.
GG.
That's really easy as well.
I don't even know what the formula for this is, bro. What do you mean easy?
We'll get to it.
Anyways,
Unless you want to do it now.
no, bro. Now is sheep.
We've been here for
And to
2.5
check if
hours.
Hexa emailed me. Do you know how many alt accounts I've created in the last 3 or 4 days for Scout?
You're
Young
on a mad ting.
Look how many different young youths I have.
It is what it is. Roadman Tings, the king year.
The man on the block. Oh my god, dude. Okay. Well, that wasn't very long, right? We started calling. Oh, 10:30. No. 2 hours.
2.5 hours.
2.5 hours, yeah.
2 hours 40 minutes. But it's